All right, we're getting into scientific notation here. Before we actually do this problem, I want to go over a few things. We have learned about negative and positive exponents. So if I look at the problem here, 10 to the 10th power, it is a positive exponent. We know that's going to be a really big number because it's 10 times 10 times 10 times 10 times 10 times. That's going to be a huge number. Now, if I were to give you 10 to the negative 10 exponent, we know we can't have negative exponents, so I would have to move that to the bottom. So that would be the same thing as 1 over 10 to the 10th. Now that's a really small number. So when I'm talking about scientific notation, I think of big numbers and small numbers instead of left and right. So here, in this case, I have 367 million. Now scientific notation is a way to make a really big number a really small number and simplify it into a number that we all can deal with instead of having to deal with all the zeros. So in scientific notation, we have to make sure our decimal is always located in between the first two numbers. So in this case, I want it to be 3.67. If there are more numbers, you'd write all the rest of the numbers. Times, and it'll always be times 10 to something. Now what I need to realize is I need to determine, is this a really big number or a really small number? So I look at this number. That is a really big number. So if I think it's a really big number, I'm going to have a positive exponent. So originally my exponent is here. I want it to be all the way over here. So I'm going to count my spaces. 1, 2, 3, 4, 5, 6, 7, 8. It is 8 spaces. So my answer is going to be 3.67 times 10 to the 8th because it is a really big number. That's why I left it as a positive 8.